Okay, guys, so we have been working on these graphs, these polynomial functions. Okay, so we got it. This one today, you got to pay attention. This is going to get a little bit harder today. We're going to be finding the x and y intercepts. Okay, so this problem is going to say negative x parentheses x minus 3, then another parenthesis, x plus 2. Okay, guys, so we have talked about this now. If they ask you about the end behavior, you need to know kind of like on the board which kind of graph you're dealing with, okay? So this problem has variables in there. You see the x's. At the beginning of the problem, there's a negative x. Then right here, there's an x, and over here, there's an x. So the beginning of the problem has a negative x. Inside the first parenthesis, there's an x, and inside the last parenthesis, there's an x. So altogether, how many x's is that? 3. So that's like negative x to the third. So what would that graph look like? So compare it to the board. It's x to the third, but it has a negative in the beginning of it. So do you know like which arrow would be pointing up and which arrow would be pointing down? Good job. The left arrow would be up, and the right arrow, she said, would be falling, going down. Good job. It'd be like this. If it's negative x to the third, it's the opposite of the one on the board, where like the first arrow is pointing up. So yeah, this arrow is pointing up, so they would say it rises on the left side, and it falls on the right. And those are like multiple choice. They'll give you a little drop-down menu. You know, you get to pick what the graph's doing, right? So these aren't terrible. You just got to really pay attention to all the variables. You got to look for all the variables in there. Okay, now today we're going to get into, that's end behavior. Now today we're going to get into finding all the x and y intercepts. This is the new thing. Okay, so I just was recapping the old thing we did last time, thinking about what the graphs look like and which arrows are pointing up and which arrows are pointing down. That was last time. Now today we're going to get into finding x and y intercepts. Okay, so this is kind of tricky, you guys. All right, let's give you an equation like f of x equals negative 3x squared plus 14x, that's 14x minus 15. Find the x and y intercepts. Okay, so we're going to write, I'll kind of write on the side, how do you do that? How do you find the y intercepts? Well, what you do is you go to the equation and you make x equals 0 in the equation. Okay, this is the rule for how do you find the y-intercepts. So you go over to this problem, and you know this f of x thing? You guys know that's the same as y equals. So we're going to find what y equals. We're going to find the y-intercept. So you go over to this problem, and where you see these x's, you make them into zeros. You change them to zeros. So it'd be 3 times 0 squared right there, and then 14 times 0, and then minus 15. You put zeros in the problem there and there. So you do the math. You can get a calculator out if you need to, but you have to figure out what negative 3 times 0 squared. Yeah, that's 0. Good job. I heard somebody say it. And then here's 14 times 0. That's 0. So what do you get if you add all this up? What do you get for the y-intercept? What's 0 plus 0 minus 15? It's negative 15. That's the y-intercept. That's our first thing. That's how you find a y-intercept. Okay, now we need to find the x-intercepts. Okay, so how do you find the x-intercept? A through S. Okay. So if you need a picture retake, if your last name's A through S. So you can go up if you need to get that taken care of. Find the x-intercept. You make y equals 0. And then you're going to have to factor this equation and solve it. This one's a little harder to do. This one was kind of easy. You just put zeros in. This one's a little bit harder. You make the y part equal 0. So this part, like the f of x, that's the y. You make that say 0. So you say 0 equals negative 3x squared plus 14x minus 15. This one's kind of hard to factor. This is a trinomial, and you have to factor it. We've done these, but it's just going over it again. We've actually done factoring, like you did your bell ringer today. That was factoring. But this factoring's tough when you have a number in the front. When you have a number in, a leading coefficient, they call that. The number in the front of this x squared. Negative 3x squared, isn't that like negative 3x times 1x? If you break that apart, see, like negative 3 is like negative 3 times 1. Negative 3x times 1x. Or I could put 3x and then a negative 1x over here. It actually doesn't matter. As long as one of them has to be negative, because it's negative 3. You break this apart. So you're like breaking that apart. Okay, then you go to the last number in the problem. The last number is 15. What times what makes 15? 5 times 3 is 15. The last number is 5 times 3. Okay, so we got to put those numbers into here. And we've been using whiteboards a lot because you can erase if you mess up, with whiteboards. You might have to try a couple different combinations till you get this figured out. Like do I put the 5 here and the 3 there, or do I put the 3 there and the 5 there? It's like a decision, and you have to check it out if it's going to work. I'll try 5 and 3. I'll stick them in here, 5 and 3. But you have to check and see if it's going to add up to negative 14. 5 times 3 is 15, but what about this middle number? You have to do FOIL. You have to check to see if it's going to add. It has to add up to this middle number. So if you check the outer, I already know like the first things times and make the 3x squared. If you check these outer ones, like this 3 times this 3 over here, that's negative 9x. And then if I times the middle, I get 5. Can I make those add up to 14? I might have to change the sign of them too. You have to make it add up to positive 14. If this would turn to positive, you could add 9 and 5 and make it, if this was positive, then I can add that up to 14, couldn't I? So this, since there's a negative there, and I want to make this one negative, so it's like negative times negative gives me positive 9. And then make this positive 5, because I know positive 9 and positive 5 will add up to positive 14. See, this is tough. You got to get the combination right to make it add up to 14. If that wouldn't have worked out, you might have to switch the numbers even and put 3 there and 5 there until you get the right combo. Okay, now you got to take those and equal them to 0, you guys. You have to take each of these parentheses like you did on the bell ringer. It's like little equations. You have to equal them to 0 and solve them. So you get negative 5, then divide by negative 3, so I get x equals 5/3. And then this one, you get x equals 3. Those are the x-intercepts. So we found the y-intercept and the x-intercepts. It's kind of tricky, you know? That's not like super easy. That's kind of tricky to figure out. Okay, I need to show you one more of these kind, and then you'll have work time. Like Mr. Danner and I can come around and help you guys. The factoring is tough, all the factoring to solve them. So let's try one more. It has x to the 3rd power plus x squared minus 16x minus 16. And we're going to do the same thing again. We're going to find the y, x, and the y-intercepts. So again, how are you going to find the y-intercepts? We just did it on the previous page. How do we find the y-intercept? What do you do in the problem? How do you find y-intercepts? Yeah, make x's equal to 0. So in this problem, it'd be like 0 to the 3rd power, 0 squared, 16 times 0 right here, and 16 there. You just have to put in zeros for all those x's, and you'll get the y-intercept. Good job. It'd be y equals negative 16. So that one's done. That one's the easy one. The hard one is finding the x-intercept. Okay, so we got this one figured out. We got y equals, okay, now we need to find the x-intercepts. You make y equal 0, and you have to factor the problem and solve it. This one's the tough one. That's the rule, though, so you know how to do each one. So the rule is make the y part, like that f of x is like the y part. You make that say 0 equals x to the 3rd plus x squared minus 16x minus 16. We need to factor that. And factoring is a tough concept to figure out. This problem has 4 parts. 1, 2, 3, 4. I see that this problem has 4 terms in it. 1, 2, 3, 4. So when you do, if you have 4 things, you have to do factoring. But if there's 4 parts, you have to factor by grouping. I'm trying to give you how to do a 4-part one. How do you do a 4-part problem? You have to do factor by grouping. Like you group this pair together and this pair together. It's not terrible if you know a 4-part one. You have to do in 2 groups. You factor by grouping, and you take out the greatest common factor. Like you look at this first pair, what do they have in common? What does x to the 3rd and x to the squared have in common? They both have x. They both are x. They have x to the 2nd power in common. Like they both at least have two x's in them. That's x times x times x. This one's x times x. This one's 3x's. So you could take out x squared. That's called the greatest common factor. GCF. Greatest common factor is x squared. That's what these two things have in common. So if you take out the x squared, you would have still an x. You know, to make x to the third, there'd be one more x. And then this would just be plus 1, because if you take x squared divided by x squared, you get 1. If you take out x squared, you know, it's 1 times x, you know, just 1. And then over here, what do you think the greatest common factor is of these? What do these have in common? Yeah, they're both negative. Good, they're both negative. What number do they have in common? 16. They both have negative 16 in them. That's the greatest common factor. So I'll highlight those. Those are the greatest common factors. So if you took out negative 16 out of that pair, what would you have left in the parentheses? So we take the negative 16 out of that, what would be left? It's like dividing it out. An x would be left, yep. What's 16 divided by 16? Yeah, it'd be 1. Negative 16 divided by negative 16 would be positive 1. It would turn to plus because you're dividing out the negative 16. So it'd be plus. It's like dividing this. I could write it in red. It's like dividing this by negative 16 and dividing that by negative 16. You're pulling it out here. So you, yeah, left with 1. So these greatest common factor things, we got x squared and minus 16. You put that together. X squared and the minus 16, that is one of the little groups that you're going to solve. And then x plus 1, the parenthesis you have is x plus 1, and you equal that to 0, and you solve it. So you put the x squared and the minus 16 together. And you put it equal to 0, and you solve this equation. If we solve those, we'll get the answers. So you can see this is going to be a little challenging, the factoring part. So Mr. Danner and I can help you too. With factoring, it just takes practice. A 4-part one, yeah, you do it in groups. Factor by grouping. Now we have to add 16 to solve this. And take the square root. When you take the square root, we've had this several times now. When you take the square root, you get plus and minus. You get 2 answers. You have to remember when you do square roots, it's plus and minus. What's the square root of 16? You know what times what makes 16? What's the square root of 16? Not 6. 6 times 6 is 36. It's not 6. There you go, it's 4. 4 times 4 is 16. So is negative 4 times negative 4, that's 16. That's why it's plus and minus. And then this one's subtract 1, this one's x equals negative 1. So you get 3 answers for that, guys. You get negative 1, and positive 4, and negative 4. Those are the x-intercepts. So factoring is tough. Like factoring is the 4-part ones, you do it in pairs and take out what they have in common. So the thing you guys have to remember is when you do a square root and you're solving an equation and it's x squared, you have to take the square root, then your answer is plus and minus. You're going to have to remember that. Like square root of 25, if it's x squared equals 25, square root of that, each side you get plus and minus 5. Or another way you could think about that, this x squared minus 16 thing, you can actually factor it some more. It's a perfect square. It's a difference of squares. You know, you could factor that into x plus 4, x minus 4, you guys. That's a difference of squares. So if you don't like the method of adding 16 and taking the square root, and you get plus or minus, it's the same as you can break it into these two things. And the answer is still x equals negative 4 and x equals positive 4. It's called a difference of squares. When you factor it, one's plus and one's minus. Like a positive 4 times a negative 4 is negative 16. Same answer as I did it up here. Square root is easy too, though. Just got to remember it's plus and minus square root. So this assignment is called Polynomials, Intercepts. It's finding the intercepts. So in the Alex thing today, look for the one that's called Polynomials, Intercepts. And you can do it, it's just the factoring is going to be, I know sometimes you'll need a little help getting used to the factoring. It's kind of tough, especially when there's a 4-part one, or when you have a number in the front. This one was tricky to solve too. We did 2 of those. Okay, so Alex assignment, finding the x and y intercepts.